All right, so this is the review for our Unit 7 test. Okay, so here are all the learning targets. These are all the things you should be able to do. If you don't know what that stuff means, then you guys should review these sections of the questions. Okay, so 1, determine what pairing below would not represent a function. Select all that apply and explain your answer. Okay, so remember, to be a function, we want each input to have exactly one output. Okay, so for instance, you and your house address. You and your house address. So you only have one house address, all right, most likely. So that is a function. Okay, because each input has exactly one output. You and your jersey number, okay, you're not going to have more than one number, so that is a function. Okay, you and all of your shoes, multiple shoes. So there's you, there's your Jordans, okay, there's your sandals, okay, there's your dress shoes. Okay, so more than one arrow comes from you. There's more than one thing. There's a choice here, right? So that's not a function. Okay, and I'm going to use the golden rule because each input does not have exactly one output. Okay, you and your grades in each class. Okay, you and your grades in each class. So there's you. Okay, and maybe I'm going to go to algebra. Okay, it's terrible. Okay, you have an A. Okay, then English. Okay, you have a B. In PE, you have an A. Okay, so not a function because each input does not have exactly one output. Okay, if you had different grades in all your classes, yes, that could be a function, but again, you just need to explain that. If you explain it properly, then it will work. If you said that is a function because I have different grades in all of my classes, then okay, that's fine. You just need to explain it. So these aren't set in stone, but your explanations are the big thing. Okay, you in your algebra class, most likely you only have one, so that is a function. Okay. Again, remember, sorry, I'm going to go back to question 1. Determine which pairing below would not. Okay, so these two would not. You could select more than one answer on the test. Okay, so first question says you in your algebra class, that is a function, you only have one. Okay, is a function because I'm going to just point up, I'm going to say golden rule. Golden rule. Okay, and that's at the top. Each input has exactly one output. Okay, you need to write this. Don't write golden rule in the test. I should probably write it out. You and your social security number, that's a function. Okay, you only have one social security number. Each input has exactly one output. Come on, let's go. Okay, letter C, you and all of your classes. Okay, you and all of your classes. You have multiple classes. Okay, so that is not a function. You in your locker. Okay, that's a function. Okay, each input has exactly one output. You only have one locker. All right. Each output of a function, number 3, each output of a function is 5 more than the corresponding input. What is the function rule? More than means addition. Okay, so 5 more than every input. So inputs are x plus 5. So y equals x plus 5. Okay, rules are always written as y equals. They're functions, okay? If you wrote it f of x equals x plus 5, that's fine too. Okay, each input is 4 less than 3 times. So 3 times means 3x. Less than is subtraction, but remember these flip. So minus 4. So y equals 3x minus 4. Okay, let's go to the next page. Okay, next page is, here's our function and here's our given value. So I'm going to take f of 2. Okay, and that 2 just gets plugged in and substituted for any x. So that's 6 times 2 plus 3. 6 times 2 is 12. 12 plus 3 is 15. Okay, so when x is 2, y is 15. Okay, our next one, okay, is f of t equals t squared plus 2t minus 4. Find f of negative 3. Okay, so f of negative 3 equals t squared plus 2t minus 4. Okay, so when we plug in negative 3, make sure that I plug it in inside parentheses. Okay, if you don't put it in parentheses, you're probably going to get it wrong. Okay, so make sure I plug that in inside parentheses. Negative 3 squared is 9. 2 times negative 3 is negative 6 minus 4. 9 minus 6 is 3, minus 4 is negative 1. Okay? Okay, domain and range. Number 7, given the quadratic function below, what is the domain and what is the range? Remember, domain are my x values. Okay, here's my x right here. All right, left to right is my x. So this goes up, but yeah, it's going right. So it goes on forever and ever to the right. This also continues to the right forever and ever, to the left forever and ever. It never stops. So the domain is all real numbers. Okay, the range is up and down. So I want to figure out, does this graph ever have a point where it stops going up or down? Yes, right here. Okay, it goes up forever, but it stops at 2 right there. So my domain, I'm going to say that y must be greater than or equal to negative 2. All right, so my graph starts here at negative 2, and it only includes y values above that. Okay, how about 8? Domain, again, x is left and right. All right, it's my x values. Okay, it continues going left forever, it never stops. And it continues going right forever, it never stops. So that means my domain is all real numbers. Okay, y values, that's my range, up and down. Is there any point that it stops going up or down? It continues down forever, all right, but it stops going up at this point right there. So my y values are going to be anything less than 0. Sorry, less than 4. Okay, any point up here never exists on my graph. If I had 3, 5, okay, that never exists on my graph. Okay, anything up here never works. All right, let's look at 9. Okay, so domain, it's my x values. So this graph goes left forever. Okay, it never stops. And this one's a little tricky. This looks like it's going down, right? But it also is going right. So I need to know that even though it's going to go right, it's going to continue going down and down and down and down and down to the right. Okay, that way forever. All right, so that's all real numbers. Okay, how about my y values? All right, it goes down and it continues going down. Okay, but does it stop going up? Yeah, it stops right here and then it goes straight left. So it never goes higher than 4. So since it never goes higher than 4, my y values are anything less than or equal to 4. All right, how about 10? So 10 is a vertical line at 3. All right, so left and right, domain, x values. All right, it never goes left, it never goes right. The x value is always the same. All right, if this was a point on the graph, that's 3, 0. If this is a point, it's 3, 3. If this was my point, it's 3, negative 4. So what is my x value always? It's always 3. So it equals 3. It's always 3. Range is up and down. Okay, obviously it points up. This continues that way, this continues that way. It never stops. So it's all real numbers. Okay, let's go to the next page. Alright, so I need to find the values of A and B. Alright, so let's look and see what happens to my graph here. Okay, what happened? What am I doing here? I'm adding 3, add 3, add 3. So A, my pattern, I'm going to add 3 to all these y values. Okay, so A equals 14, B equals 17. Okay, given the table of values, find A and B. 17 minus 3, minus 3, minus 3, minus 3. 8 minus 3. A is going to be 5. Okay, 5 minus 3. B is going to be 2. Okay, I'm going to go up to 13. So use your graphing calculator. Okay, I'm going to use my graphing calculator. I'm going to clear everything out. And I'm going to enter that in. I'm going to go to y equals. Okay, let's start over. Going to y equals. I want to enter x to the 5th. Okay, I have an older calculator, so I need to put this in parentheses. You guys, when you hit that caret, it'll just go up. Minus 5x. Okay, once I have that there, I want to go ahead and graph it. Okay. It's a little funky graph, all right? We've never seen one really like that, but it doesn't mean we can't identify the domain and range. We actually only have to find the range. So range is my y values. Okay, that's my up, down. Okay, so going up and down, this graph goes down here forever, comes up, it goes down, and then goes back up. So possible y values, since this continues going up forever and it continues going down, I know it has these starting points, but that doesn't make a difference. At some point, a y value could be anything on the graph, so it's all real numbers. Okay. Okay, 14. Okay, I want to find the domain, so I need to go back to y equals. I'm going to clear that out and I want to enter this in. So I'm going to put x squared plus 2x minus 3. And I'm going to hit graph. It's going to go ahead and graph it. Okay, and I want to identify the domain. So this is a parabola. I know domain is x values. So that's left to right. Okay, going left. This goes up and to the left and it keeps going forever and ever and ever. This way it goes up to the right, it goes to positive infinity, it goes on forever. So if it goes left and right forever, it's all real numbers. Okay. Alright, the last one, we want to determine which relation is a function. Alright, so using mapping, okay, I want to determine if any of these x values, alright, or any of these ordered pairs have the same x values. 0 goes to 0, 2 goes to 1, 4 goes to 2, 6 goes to 2. None of these ever repeat. I never have two lines coming from one. Remember, we said in class, if you ever have a choice going from any of these x's, okay, then it is not a function. But this one is a function. Okay, if I wanted to write all these out, I would have 0, 0, 2, 1, 4, 2, 6, 2. Okay, my x values never repeat. One of my y does, but that doesn't make a difference, so it is a function. Okay, from ordered pairs, do any of these repeat x values? Remember, it's x, y. 3, 4, 5, 5, so not a function. Okay, my C and D are both graphing, so that's vertical line test. That's nice and easy, so I can take my pencil. Okay, at any point, does a vertical line touch my graph twice? Well, I could draw one right there that touches here and here. One there that touches here and here, so that's not a function. Okay, and this one, same thing. If I take my vertical line, my pencil, okay, right there, I see it touching my graph twice. Here and here. Here and here. So that's not a function. Okay, so A is the only relation that's a function. Okay, guys, second video we'll have the rest of the questions. Good luck, guys.